Greetings to you, ladies and gentlemen. Welcome to Shexa's YouTube channel. Please motivate me with your likes, thumbs up. I get motivated by likes. And if you do not like this YouTube content, um, give me a meaningful dislike through some comments. Give me your comments, suggestions, and other things that you think we need to discuss through comment section. And if you feel that other people needs to benefit from this content, please share with your friends, colleagues, and whoever you think needs to view or watch this. And most importantly, do not forget to subscribe so that you don't miss out any new videos that I upload. I might fail or forget to share the link with you. So if you want to get the latest videos that I upload on this channel, please subscribe and click the notification button. Today we are going to talk about database management and warehousing, and we are focusing on practicals, and these practicals are based on SQL queries. And the SQL queries that we're going to write today, they will help you in creating database objects. And if you want to destroy the database objects, this is the right lecture for you. And all other things that are relevant and related to the creation and destruction of database objects are also going to be covered. And some of them might not be covered in detail, but be prepared to have them on another lecture. And if you feel that I have left some other things that are very important, please make sure you note them down, or just give a comment which is related to what you think is supposed to be covered or done. Right, here are the things that we're going to do. The first thing is, in fact, the whole thing is about the creation of a simple database that we are going to create from scratch. And whatever the platform that you are using, for as long as it's allowing you to write SQL statements, then don't worry, we will write the SQL statements to create the database. And here are the areas that we're going to cover. The first thing, we shall look at a database structure generally, to say this in our mind we have this, we talk about it, that is, we conceptualize our database so that everybody following can understand what we want to have before we create it, so that it's more like we start with the practical theory. I don't know if you get it, the practical theory, to give you the practical into your mind, so you get the picture, you get the image of what we are going to do today. And then after doing that, we create a database. We start the database object creation. That is, we create our database named track management database, that is track management DB. And the other thing is, we're going to create our tables, and that's where the main issue is. If you can't create a database, then you can't proceed. And then if you you can't create tables, it means you cannot create a database. Right, and the following are under table creation. When you create a table, there are several things that are looked at or that are being evaluated. we for your table to be a strong table or a reliable table for relational database, it needs to have the following constraints. That is entity integrity, referential integrity, domain integrity, and maybe other constraints that that may be relevant to your database. But for today, we're going to cover those and how can they be implemented, how can they be enforced, and what are they? What is it that you call entity integrity? What is it that you call referential integrity, domain integrity? So let's do it practically, and other constraints are to be covered later. Right, let's start with the general understanding of the database structure to be created. Our database is going to manage what? Tracks. Since we called it track management database, so it's going to manage tracks. And a database can be created for anything, for as long as you have an entity or more entities that can have records to be kept in a relational database. Right, so we start with a track. A track is an entity. And what do we mean by an entity? An entity is a real world object. For instance, I can say a vehicle, a truck, that's an entity. I may say a computer. A computer is an object. A mobile phone is an object. A container, a water container, or a lunch box is a what? Is an entity. It's an object. So these are the objects that we have, and for this database we have tracks. So tracks is our entity, and this entity is defined by certain attributes. And the attributes includes the reg number, that is the number plate. We have the make, model, service, and mileage. And these are the columns, or these are the attributes, or these are the fields for this entity. So these fields or attributes, they describe our entity. For instance, we can say, what is the make of this track? Or who made this track? And what is the model of this track? Was this track serviced? What's the mileage? What's the number plate? Can you give me the registration number for this vehicle? In other examples, we can say if it's a stock management system, or it's a let me say it's a computer database. You can say laptop. I have a laptop. A laptop is an entity, but now we have different models. We can say this is a laptop, this is an HP laptop, and what color does it have? And then we have a serial number and other things. So for this database we have tracks, and then we have drivers. All these are entities. And then we have trips, we have truck driver relation. Right, so by this these are the three tables, these are the four tables that we have, or four relations. And from this you can see that some of the attributes are underlined by one line, some are underlined by two lines or double lines. it means something. Those attributes underlined by one line, they are called primary keys. In those with double lines, they are called foreign keys. And these foreign keys, they are unique attributes in other tables. So you need to be very careful there. I didn't say they are primary keys. I said they are unique in other tables. So in the secondary table, that is truck driver, that's the secondary table. And the primary table might be trucks. And in trucks, we have reg num. That is the reg number. Reg num is unique by the fact that it's a primary key. It's unique. Therefore, it becomes a foreign key in truck driver. Same applies to ID number from primary table drivers. So truck driver, it links trucks and drivers. You will see in future as I will show you how these tables are related. Right. So you can see here we now have our table, the normal table that everybody understands. And we have something added. Since we said trucks, that's the entity, and here is the table. This is the table with attributes, reg number, make, model, service, and mileage. Right. So what do we have here? We have row number 1, or tuple, or a record. So the first record that we have is a vehicle with the registration number ABC 1234, and this vehicle is a Toyota Corolla serviced with mileage 35,007. So you can see that I am describing a vehicle. I'm saying it's a vehicle, or it's a truck with registration number ABC 1234, and this vehicle is a Toyota Corolla serviced with mileage 35,007. So that's an instance. If you point it to that vehicle, that's an instance of an entity. That's an instance of an entity. It's more like we have one object which is representing truck's entity or truck entity. And then if you point at the second row, that's another tuple, and that's another object, that's another instant, that's another instance of an entity. So that's the table. Same applies to other tables that we have. We have drivers, and we have several drivers identified. Each driver is identified by an ID number, and each vehicle or truck is identified by the number plate or the registration number, as illustrated before. Then we have trips. These trips, we have a trip from Harare to Bulawayo that is taking place, and from 26 to 30 March 2021, and the fuel is 500. So these are the trips that we have. We only have 2 trips, but the driver or vehicle going to these sources and destinations are not signed. So that's what we have here, but let me just add them. So let's just say here we have 06AB, and this is not underlined. because these are the values themselves. So here we have 09 CB. So that's this is what is happening. You will see in the next slide what exactly is happening. So here are the truck driver ID. So this is the truck driver ID. We have 06AB, 06AB here, and here it's CB, and it's not underlined. Right, so that's what we have here. And then truck drivers, it's linking to say this driver is having this vehicle and this driver is assigned to this vehicle. And then we can say, by knowing this truck driver ID, we can tell to say which driver is driving which vehicle. And if we get to this point, we can say which driver is going where and with which vehicle, and how much fuel is that person using or has used for this trip. So we have two trips, Chinoy to Harare and Harare to Bulawayo, and these we have two drivers and two vehicles going these two trips. Now let's have a general understanding. This is, I think I've talked about this. Trucks, that's what? That's our entity. That's a real world object. A truck is an entity, and we have several examples, like I said earlier. A laptop or just a computer, I may say a computer, maybe type, that's an attribute. And then we have attributes. These are the attributes. And color is an attribute, column or field when it comes to databases. Make is an attribute, column or field. Model, and many more. Right, so we have this table, and each truck is identified by reg number as underlined to show that reg number, that's the primary key. And when we say this is the primary key, what do we mean? That's entity integrity. That's data integrity. We are saying to identify this row, we identify it by reg number. To say this vehicle, can you identify your vehicle? Maybe there are 30 vehicles and your own is there, and you are asked to identify it. Usually colors may be identical. You may have 30 red cars, 15 red cars. If you have an endless list of vehicles available and yours is included in the list, you may say, can you give me the reg number of that vehicle? Then you say, this is my vehicle or this is not my vehicle. And then we go to drivers. Each driver is identified by national ID number. First name, last name might be identical. You may also identify a driver by phone number. Therefore, it's going to be unique. Email address, same applies, it's going to be unique. So this is what we then call domain integrity. This is part of domain integrity. So I want to let you know that domain integrity covers is defined by data type. It is covered by data type and the length. That is the number of characters that are allowed within a certain for a certain value. Then we can also talk about all possible values. If you don't allow negative values and you allow positive values, you are defining domain integrity. If you say this is the default value for this attribute, then you are also defining domain integrity. So we also look at that when you are asked to write or to create a table. And then we have trips, and these are the attributes as discussed earlier. So some might say, this guy is repeating what he once said in previous slides, but no, I want us to understand all versions or all views that you may encounter when talking about databases. And this is the truck driver relation. Right, let's now see referential integrity. Referential integrity is enforced by two keys. The first one being, I said two keys, not two keys. I don't know, whatever. But by two keys, the first key being the primary key, the second key being the foreign key. So the foreign key exists in a secondary table, and the primary key exists within the primary table. Right. So let's see what happens. We have a reg number, and where do we see it in another table? It exists within truck driver. So that's the relation that we have. ID number in truck driver is a foreign key. So let me talk about the first relation that we have between trucks and truck driver. So we are saying this truck with this reg number here, it's identified as what? As that's the registration number for this truck. So the registration number for this truck, and then who is driving this vehicle, or who is assigned to this vehicle. It's a certain driver with an ID number of this, and this ID number is a primary key in a table called drivers, and more details about this driver exist within this table. And now we can say we now have trips. We now have our trips, and truck driver is linked to trips through a truck driver ID that exists within trips. So we are saying a certain trip, we have a trip from Chinoi to Harare, and who is going there with which vehicle. You can see this through the relationship here. TDID, that's truck driver ID, is existing in trips as a foreign key. So that's a referential integrity. This reg number is referring to reg number in trucks. This ID number is referring to, you will see when we start to write the SQL queries, the language that I'm saying here is exactly as what I'm saying it. I'm saying in truck driver, reg number is a foreign key which is referencing reg number in trucks. Same applies to ID number. I am saying ID number in truck driver is referencing the driver's ID number which exists within driver's table. Same applies to truck driver. Truck driver ID in trips is referencing truck driver ID in truck driver table. So that's it for our table and the relations. So this is a referential integrity, and I have also talked about domain integrity and entity integrity being enforced by the use of primary keys. Right, so let's now talk about let's now go to the practicals. All right, so let's open our workbench, and some might be using Navigate to get to their SQL or to their MySQL databases. So let me open Workbench, MySQL Workbench, so that we start the creation of our database and the tables, and you will see various ways of doing this. Right, so this is my MySQL Workbench and I do have several connections. This is the one that I have, and this is the one that I'm going to use for this lecture. Right, so these are our databases. If you don't see this, maybe you have opened on administration, so you need to click on schemas so that you see all the databases that you have. And this is our editor. We can write our query here. So what we are going to do is I am going to create, I'm going to write a query to create a database. And the database that we want to create is called track management database. So we say create. It's not case sensitive, so you can have create a small caps or as caps. So I can say create database. So create is a what? Create is a data definition instruction or data definition command that is used to create database objects. And when you want to create a database object with create, what you do is you write the create command first, followed by the type of object that you want to create. And in this case, it's a database. That's why we said create database. You will see when we create another types of objects like tables. And then you can give the name. You can specify the name of the table. You can specify the name of the table that you want, of the database that you want to create. And in this case, our database is called track. Let me just put it in small caps. Track. Track management DB. So I'm separating all these words. It's just one word. Track management DB is one word. But if you look at this one word, it's having several words combined together but separated by an underscore so that it becomes readable for the users. So when we program anything, we program in such a way that if I die today, if I resign today, anyone else who is going to take my position will carry on with the project or the projects that I have been working on. So any other programmer that is going to take over from where I have left must be able to understand whatever that I have been writing. So that's one of the qualities of the best program. Right. So this is the simplest way. So I'm going to put a comment here. To put a single line comment, you just put these two characters, two minus characters, or two, what do you call them? Or in other words, you can put two hyphens here and then put space, and then you type in your comment and say simplest way of creating a database what object, right? So this is the database, but here we have three databases or three schemas: Shexa test, system, track manager, but ours is track management DB. And then you click on execute, and then the results of our execution appears at the bottom. That is the action output. That's the action output. So create database, this message, one row is affected, meaning to say we have successfully created our database. And this green icon with a tick, it tells us that we have successfully completed the task of creating a database. So we are done creating a database, but this is the simplest way of creating a database. But there is a high risk of writing such a statement. What if I try to rerun or to run the same statement once again? You see, I will get an error which saying error code that can't create database track management DB database already exists. So instead of getting an error, what else that is better? What can we get that is better than an error? What can we get that is better than an error? We can get a warning. So to get a warning, we can say create database, if not exists, like this. So if you run this, you see we have this icon with an X, red icon with an X, which is telling us that this is an error, and this icon shows that it requires attention. So if I run it now, instead of getting an error, I'm now getting a warning, which is saying can't create the database track management database already exists. So this one is no longer the simplest way, although it's simple, but it's checking first before creating. So this is the recommended way of creating a database. So what I'm going to do is I will delete this if not exists here, and then write this statement here, this same statement, create database track management, right? So before I do this, let me just finish writing this. Let me just paste it there, and then if not exists, right? So this one does checking before creation. So I will stop writing these comments so that I may write them later and share with you in the description, or I can share the SQL queries with you as files on email, right? So if I want to comment this, I can put these two hyphens and space. Right, so how can we now see the database? It's not there. We can click on refresh. If we click there, you will see that track management database is now there. You can see track management database is now there. Now we are done creating this, so we just comment it, and then we write another instruction. And the instruction now is we need to use this database. At the moment, you can see that Shexa test is the database that is bolded or that is selected. But is this the database that we want to use? That's not it. So we want to use this database. So the first instruction to use is use track management DB. So that's it. We run it. Now the moment you execute it, you will see the highlighted or the one selected database being bolded in black. So that's the database that we are now using. So this instruction is not going to be commented out. So before we go anywhere, let me give you another way of writing a multiple line comment. So if you want to write a comment with multiple lines, you can put a forward slash and an asterisk. You put your comment here. These are 2 lines, and then maybe the third one. Whatever you want to you put your comment here saying anything about your code. So what we are doing here is we are writing a comment with more than, so we have multiple lines here as our comment, and single line comment is written like this, right? So this line, which is saying use track management DB, is going to be executed every time we run, but there is no harm if you comment it out after running it once, right? So we now want to create our table, and our table is going to be created. Let me just open our, let me open this one. Okay, this one is still fine, but I can just go there and click here. Right, I want us to see this table. Right, so we want to create a table called tracks with these attributes, right? So open our workbench or whatever the platform that you are using, and then we say create. Now we are still creating database objects, and what type of object are we creating right now? We are now creating a table. So we say create table, and what's the name of the table that we want to create? The table is called tracks. So tracks is, what's going on here? I'm opening the things, right? So tracks is going to be created like this. Create table called tracks, right? So when I say create table called tracks, I'm going to put these brackets, and these, within these brackets, I'm going to define each field or each attribute and its domain integrity constraints, right? For instance, I want to, we have our table with what? It's having reg num, so I can say reg num, and then reg num is of what type? Reg num is of here we put our reg number, and then we state the data type. So that's domain integrity that we are enforcing here. It's a variable character, and variable character includes alphanumeric values, and then we state the number of characters that are allowed, and we may say let me just allow 16 registration number, but it's only 7. Let's just put 7 here, and then we put a comma, and then we state another attribute. Another attribute in this case is make, and make is of what type? It's a variable character. And then here we say what? Make might be Toyota, Honda, and so forth. So it might be of size 64, put a comma, and model is of type variable character. It's of size 64 as well. I'm just using 64 as my default for long variable characters. Serviced variable character vocal, and serviced or not serviced, let me put 10 here and just put 12. And then we have what? Mileage it's integer, right? So I want you to note something here. So if I say int, I might also specify the length. I can say this is mileage. It might have five digits. Well, let me just say it might have 8. Right? You will see what will happen. Now let me enforce entity integrity. Domain integrity, we have enforced it here using data type. And data type, we are referring to the type of information that is going to be that is relevant for a certain variable or attribute or field or column. For example, when we say make, are we going to put numbers when we are requested to enter the make? When we are requested to enter model, are we going to enter numbers, or we're going to enter characters? So when we want to enter characters, by characters I mean a full stop, numerical values, other characters such as underscore, plus sign, and other things, and other characters, alphabetical characters such as A, B, C, D up to Z. So these are the data types. When you are asked about mileage, can you give me a name to say what's the mileage of this vehicle, and you say ABC? Is ABC a mileage? No, but an integer, for instance 35,007, that's a mileage. So let's now, I think I'm done with the data types. Maybe if it's price, you may say double or float because it's containing a comma. I will cover data types in a specific dedicated lecture in future. Right, so here we say we now want to enforce entity integrity, and entity integrity is enforced by primary key. So I just say primary key, and I state the column or the attribute that I want to use as the primary key, and in this case I have reg num. So reg num is going to act as my primary key, right? So I say I terminate, or I put my full stop. So a termination is the full stop, or it tells us to say this is the end of my create query. So this is the query that is going to create our table. So if you click here, there are no tables, but if you now run this query, if I run there, you will see that it's running here, and it's having a warning. And what is the warning here that we have? What is the warning? Warning. Integer display width is deprecated and will be removed in future release. So what is it that is that we are being told here. So what we are being told is this length, or the length, or the number of digits that are allowed is going to be removed in future. So if you want this query to be executed in future versions of MySQL, you might need to remove this. So let's talk about how one can drop. Let me try to run this as well. You will see that I'm given an error. So what do I need to do? I need to check before I create a table. We need to check before we create the table. So what we do here is, let me comment this. Let me comment this. Let me comment all this, right? And then write a statement to drop or delete or destroy this table. So if you want to check whether the table is there, you can refresh and see that we now have tracks with the following columns. The following columns, these are the columns, right? So what you may want to do is, we will now want to destroy this. I think we didn't destroy our database earlier. I wanted to show you how one can destroy a database. So here I can say drop. I want to drop this table. I want to destroy it. I can say drop. You state the type of object to be destroyed, and in this case it's a table. And what's the name of the table? It's tracks. And put a full stop, then you execute. It's deleted, it's no longer there, it's gone. So it's totally destroyed. Right now let's destroy our let's run this again. You will see that it's giving us an error, and to avoid an error and get a better notification that is a warning, you just say drop table if exists. So you are saying if it's there, drop it, but if it's not there, just tell us. So drop table, we have a warning, unknown table, meaning to say it doesn't exist, it has been deleted already, right? So what are we going to do? I also want to destroy. Let's also drop. So we now want to use the advanced way of dropping. We first check and then drop. So we want to drop our database and then later create it again. So we can drop our database. So let me remove this. Drop database called what? Track management. So we drop if exist. If exists and if not exists, these two you need to be very careful. If it's there, you delete, and if it's not there, you create. So let's run this. Right, it's deleted and you cannot see it, it's no longer available. So if you want to create it, I think we've talked about this earlier. If not exist, then you run that. Right, it's this that is causing us to have an error. Run that. It's created. We refresh. It's not there. We remove this comment so that we use this database. Right, so you have seen that using this use track management DB allows us to put our focus on this. So let's just run this and then maybe change our focus and say we want to work with this one. I just double clicking on it, and then if I want to create a table, you will see where the table will be created or will be added. So let me comment this out and write so all these commented statements, they are not being executed or they are not considered as SQL statements, right? So what I will do is I will say create, right? So create table called tracks, right? And terminate. You will see where this table is going to be created. Let me execute it. Create table error. A table must have at least one visible column. Okay, it's fine. I think I thought it's a database, right? Let me add the columns. Let me just copy these parameters and put them in there, and then let me put if not exist here. If not exist, this is what differentiates students who pass and students who get distinctions. So you need to know what to put. Try by all means to add all constraints that are necessary, and if you add an unnecessary constraint, it shows that you really don't know what you are doing. All right, so I will run this and you will see key column read num does not exist in table. Okay, it doesn't exist there, so we run. It's running, so it's creating, right? So get a warning: create table if not exist integer display with width is whatever. But do you have our table created? Yes, it's created, but it's created under tracks, of which we do not want to have tracks in Shexa test. So what do? We say create table if not exist, and then we may state to say I want this table to be in track management database dot. So this is the name of the table that we're going to create, and we're going to create this table inside this database called track management DB. So we run that. Error, even error, check the manual that corresponds to that. Let me check the error message here. On line one. What's the error? In this first line, track management DB. Right, I think this version does not allow us to write the name of the database here. Maybe it's because of the version, but if you are using Navigate, let me say here I'm using Navigate. Let me just say here inside, let's say I have created a database new query. I can say create a database called track management DB if not exist, and run it. So you can see here I have these databases And if I execute my query here and run it, right, affected rows, it has been created. So I will come here and refresh it. You see track management is created, and I can still write another query in here to say I now want to create I want to create a table. So I say create let me just copy the query that was rejected here. Let me just copy it here from here and then paste it here to check if right, and run it. It's running perfectly, nothing changed. So with this navigate, it allowed me to write this same query. So it depends with the version. So you can see that on this workbench, it's workbench 8.0.13 if not 23. It's not allowing me to specify the database here, but it allows me to use the use command. So I will use the use command instead of specifying the database. So it doesn't matter if you are asked and you write that query, but you might need to know, or you might need to specify the version of the platform that you are using. So if I run it this time, it's going to create a table, and I'm sure the table is now created. It's now there. But to avoid getting this comment, this warning, we can remove this and then maybe drop. So it's good to say, if you want to create a new table every time, you may start by saying drop table if exists, and then you specify the table tracks, and then you terminate, and then you create it once again. So I can run this, and you will see that it will be created without any warning. If you want to see this, let me remove this first and run the drop, so that we remove the tables. We no longer have tables here. Do we have any tables? No, right? So if I now create a table without specifying here, you will see that I will no longer get the warning. It's now running and created without any warning. So that's it. I think somebody asked me one day when we were doing practicals about the creation of database tables. So that's it. Now let's create. So if you don't want to delete these queries, make sure you put this statement first, so that it drops whatever is in existence, and then create a new one. And then here but for the sake of this, I will just comment all this. Right, so if you want to comment everything once, you just highlight everything that you want to comment, and then you press control / so that everything is commented. And if you want to remove the comment, you highlight everything, and then it doesn't work here. You just undo. Right, so that's it for creating this table. Let's create another table. And another table is what? It's drivers. So we start with primary tables, so that when we want to specify or when we want to enforce referential integrity, we will specify or we will reference an existing table column. So we start with the tables without foreign keys, and in this case we're going to create a drivers table. So what we do is, if drivers exist, we delete it. So we start by drop table if exists, and the table is going to be drivers. Now we create our table. So this is good practice. Create table, and the name of the table is table, but we create if not exists. So this we are ensuring safety. Create table if not exist, and then the table name is drivers. And I'm sure that the table is not in existence because I've written a drop statement there. But you need to be very careful with this statement, because you might drop it and lose some data if the table is having some records. So be very careful. Be very careful with these statements. So here I now specify what do I need to specify here? The columns. And what are the columns? I have first name, last name. Normally we start with the primary key, but let me just say ID number, and this is what variable character, and its of size what, let me just say 16 here, and then put a comma. Before I put a comma, I want to illustrate something. Previously I've stated at the end to say this is my primary key, but now this time what I'm going to do is I am going to let me enlarge my fonts. Let me put 20. Put 20 there. Right, so I'm going to save this so that when I restart it, I want to save this one, this query. I want to restart so that right, and restart my workbench. Some are complaining that they're not seeing, so let me open my workbench again. Right, and it's still opening in that last query. So I'm saying I was saying previously we have talked about enforcing entity integrity here in this way. So here we are enforcing entity integrity, right? So here I want to enforce entity integrity here, and I'll just specify that this is the primary key, and I'm done. I am done specifying or enforcing referential integrity. Right, so that's it for this column or attribute, and then we go to the next one, create table if not exist. Then we go to the next one, it's so point first name, last name. So we say f name for first name, and it's a variable character. of size, let me just say 32 here. Let me just say 64. Some are having a lot of a long some are having long names. Let's say it name, and this is variable character. It's of size 64. Let me move as fast as I can. We have phone and phone. So here I just said phone because that's what I chose. And phone is what? Let me can I have it as int, or can I have it as variable character? Let me just put it in variable character, and it's of size 16 as well. Let me just put 16 there. And this, now I'm now enforcing some domain integrity constraints here, and it's not now. I'm not accepting now values. What else can I talk about? It's unique. What else can I talk about? This column. Let me just end there. Right, not now, and unique, because I need to call my drivers. And the next thing is email address, and email address might be, it's a variable character, and it's of what size? Let me just say 128. Right, so this one is unique. So you can specify as many constraints as you wish per attribute or per column. So not now, I'm commenting here. Not now means no no values are allowed for this attribute or column, or maybe field. Right, so when I say not now, you cannot leave this attribute blank when you are inserting values. When you are entering data, you cannot insert now. And this is unique. By just saying unique, it's also going to be not now. So you may, if you say unique, you may not need to say not now, because by saying unique, it's not now already, or it's not now by default. Right, so that's it. I just I just put them both because I wanted to show you that you can add as many constraints as you wish. Let's now run it and check if it's going to run. Wow, it's created. Let's now check our tables. We have one. Let's refresh. Now we have drivers, trucks. So if you click, you will see all the tables, columns available here, and you will see that you have your primary key underlined and bolded with PK at the end, and the structure is defined there. If you double click on drivers, you will see the same, but unique column is bolded, and all other columns with specified constraints, they are bolded, as you can see from this interface. Right, so that's it for this column, for this table. So you can run this, because I have this statement. I can run this without getting an error, because it's dropping it first and then adding it. So you will see, if I try to refresh this, let me refresh, run. Okay, let me comment this first. I can run this. It has been created, right? I now have it. I must have it. Right click here, refresh all. It's there. But if I run, I want to check something here. We're experimenting. I've deleted it. It has been deleted by this statement, and this statement must have created it. So let's refresh and check. So there, I can run it as many times as I wish, but you see that it's deleted, but it's created as well. So if I refresh, I will see it. So that's what makes you a distinctive student, if you know all these things. So let me comment these queries. If you want to copy these queries, just pause the stream and watch or copy the statements. If you face any challenge, put them in the comment section. We are available to help you in there. Right, so I'm going to comment this. You will say control / I've commented over everything. Now we have what else do we have? It's here. We have trips. Let's now create table trips. So I'm going as slow as I can, making sure that I show everything, every part, every step that is needed or that is required in creating these database objects, and defining or enforcing some constraints. Right, let's now create the trips table. We now know the best way of doing this. First, drop it if it's in existence, but you need to be very careful with this drop SQL command. So we say drop table if exists. Right, drop table if exists, and then what's the table? Trips, right? So if you run, you find that you get a warning because trips is not in existence. It doesn't exist. Drop table if exists, warning unknown table track. You see here it's specifying that it's not available in track management DB. Okay, so that's it. You write the query to create the table. Create table. We create table if not in existence. If not exists, and the name of the table is trips, and then we put our opening and closing brackets, and then we write if. I wanted to say if here, if not exists, right? So I'm going to write what am I going to write? The first column. And what's the first column? Trip ID. So TID, and in this case I want my trip ID to be an integer. Since I don't want to get any warning, I'm not going to put length. And what is it that I want to add? This is my primary key, so I can say primary key, and I want this to auto increment. Right, so I'm done with my first column. Second column is source. That is where I'm coming from. So I want it to be source like this, so that I don't use the keyword. I don't know what source is going to do to my database, so I just say source without e, and source is going to be a variable character. Since it's going to be a destination, it's going to be a city or place, and I'm going to put once 255. Yeah, it might be very long, and I don't want to accept now values, so it's not now, because these are main attributes of the table. You can say I have this trip without source, without destination, so I cannot have now values here. And then destination, so destination, you can say dest, and you have it is variable character of size 255 plus, and it's not now as well, but the trips can have same variable, same source, same destination, but with a different departure date and arrival date or return date, so it's not unique. And the next attribute is what? The next attribute is depart date. So depart date, depart date, and depart date I will put as a data type date, and return date, and this is also date. What else do you have? Fuel, so this is the amount of fuel to be used or used for this trip. So fuel is a double, so it's a double. I may not specify the length, and trip ID, truck driver ID, and truck driver ID, this is referencing what you see. So we've made a mistake of starting to create this trips table before creating this one. So this one is a secondary table to this table, so we need to start by truck driver table instead of this. So let's just comment this, we'll come back to this later. All right, it's okay, let's just write it and see the error that we are going to have. So TDID is going to be, let's just say call it an int, and that's it. Go back, go down. We now want to specify, we've specified the primary key, and now let's specify the foreign key. We say foreign key, and then we specify that TDID, that's our foreign key, and it's referencing what? It references a column which is in which table. The table that is being referenced is truck driver. It's referencing truck driver, but truck driver we haven't created it yet, so let's just write truck driver, and the table that we are referencing is TDID. The column rather is that one. So we are done creating that, but there's another constraint that we need to specify here. Okay, it's okay, let's try to run it and check the error that we're going to get. So create if not that failed to open the referenced table truck driver, so it means that the table truck driver is not in existence. So let's comment this, we'll come back to it later. So we want to create it here, so we say create, let's be professional, drop table if exists, and what's the name of the table? Truck what? Driver, and then we create it. create table if not exists, and the table is going to be called truck driver, and then we put all the attributes inside these two brackets. Here I have an error, it's supposed to be an underscore, and then I do this. We now enter the attributes. The first attribute is truck driver ID. This is going to be an int and a primary key which auto increments. Then the next one is what? Driver ID number. So I just say, I can say driver ID number, and this one is a variable character, and it's of size 16. And then the next one, and this one is not right. Let me just say registration number, vehicle, truck, let me say truck reg number, and this is variable character, and it's 7. Let's just say 8 here, or just say 16, because some people use their names as registration number, but we need to be consistent, because when we created reg number in trucks, we said it's 7, so let's just be safe, put 7 there. And let's now enforce referential integrity, because if you open this, it means this one is linking this table and that, and also that. So ID number is a foreign key, so let's put the reference, and here we say this foreign key, and our foreign key is, the first foreign key that we have is driver ID number. We put it there, and it's referencing what? It references drivers, and the column that is being referenced there is what? I think we called it ID number. Let's just click here, or just double click there. The column that we are referencing here is ID number, so it's ID now, right? But there's another constraint that you may add. So what happens is, if you delete data in the primary table, that is, if you delete a driver, if you try to delete a driver with this foreign key constraint, it will give you an error, because you cannot delete the parent record which is having child records. So if you want to delete a driver and also delete truck driver record, what you do is you specify here to say on delete cascade. So this allows you to delete the data in this table if a certain driver linked to a certain record in this table is deleted in driver's table. So we put a comma and put another foreign key constraint, foreign key, and then we have this is our foreign key, copy it, paste it in there, and close, and then it's referencing what? Reference is trucks, and in trucks, which column are we referencing in trucks? it's regional. So it's regional plus we say on delete. So on delete cascade, it removes the records in this table if a certain value is removed from the parent table. So for instance, we are having this table. Let me show you here. We have these tables and their relations like this. If you want to delete a track, but this track is linked to a certain driver in this table, it means you will need to delete data from this track driver first before you delete the track. Same applies to the driver. If you want to delete a driver, you need to delete the driver that is linked to a certain vehicle in this table first. You need to delete the record which is related to this driver from track driver first before you delete it there. So if you try to delete it without putting the on delete cascade, it will not allow you, it will give you an error to say you still have records linked to this record that you want to delete. So it will not delete because it tries to maintain referential integrity. We cannot have a vehicle linked to a certain driver who is not in existence. We cannot have a vehicle linked to a driver linked to a vehicle which is not, of which the vehicle is not in existence. So that's what is being enforced by these two primary keys, and that's what is being enforced in our query by on delete cascade. So we leave it like that, and then we run it. We run it. Yeah, it's running. Right. So we have our table. So let's just refresh. We now have our 3 tables. Now we can uncomment this. I don't know how to quickly remove these. Maybe if I do it this way. It's not deleting. So let me delete all these comments and effect our table. Right, so here we are now creating our trips. So we cannot have a trip which is not having a driver and a vehicle. So same applies here. So if we want to delete, we need to enforce on delete cascade. Right, so let's comment this so that we may not need to comment it. So we run, it's created, we refresh everything. We now have truck drivers. Trips is not there. I'm not seeing trips. Okay, let me run it once again. It's running. Trips is not there. I don't know what's going on with our. Okay, so what I'm going to do, I'm going to comment all this. Oh, no, I don't want to comment everything. Right, and run this. Maybe you're having an error, so it's executed. Let's check. Right, we now have our trips, and our referential integrity is enforced. So we have now created our tables, and you can copy these queries, these SQL query statements to create your database. So we now have this is what we have. This is exactly what we have. This is exactly what we have in our database. This is exactly what we have in our database, right? So for today, I think it's enough. Make sure you create the databases. Make sure you create the database and the database tables as instructed. So what I'm going to do now is I'm going to open all the queries that we have created, and have them as one file so that you can copy everything, and maybe I can paste it in the description so that you can copy all the queries and run them. So, and I think this is also going to help us to run through what we have done today. So create database if not exist. So I'm going to delete all the comments so that you can clearly see the code. So create database if not exist, but before we do that, let me just add a drop database. You now know all these things. What drop means, what are you dropping? Drop if exists. And why do we put exist? Why if exists? And the database is track DB. Then we terminate, right? Drop database if exists track management DB. We are done. And then here we use that database that we have created, and then we create our table. And then I don't want to use this simple way of creating this table. I want to use this one. So we drop first if it's in existence, and then create database. I don't want all this. Now we create the table. I'm just removing the comments that we have added earlier. So that you have a clear picture of everything that we have done today. And next time when we come in here, we are going to enter or insert some data. After entering some data, what we do is we play with some queries about deleting, updating, and other queries. And then drivers, if not exist, drop that if exists, yes. Right, you drop here. Just removing the comments. So you can have this as your backup SQL file. Right, so we delete everything. So this one, I think it's nothing, it's not supposed to be there. Right, so this is the order that you create all the tables in the database. Like, so if you want, you can pause. So we create our database. We first check if it's in existence and drop it. Be very careful. Be very careful with these statements. Be very careful. And don't be careful. You need to be careful, not careful. Not careful, right? You create the database. You need to be very careful with the drop SQL command. Use, you specify the database that you want to use. You now drop anything that is in existence in that database. You create new, you drop, you create, you drop, you create, you drop, you create. And then if you want, you can now execute the whole SQL file. So you see, we no longer have the database here, but now other query statements are now being executed, and now we are done. If we refresh, you will see the database created here, and all the tables are there with the same structure here. So I can save this SQL save script as track management DB creation query. So if you want this query, I'm going to send it to you as one query, but if you want bits and pieces of these queries, I can also send them to you. So thank you very much, ladies and gentlemen, for being with me all this 1 hour 36 minutes, if not more. Please don't forget to subscribe, like, comment, and give me your suggestions in the comment section. I've enjoyed being with you on this platform. For all queries and other things that you need, that you think you need my assistance, I can assist you if you are facing challenges through TeamViewer and other things. Maybe you're at work, you're facing challenges as a new database administrator. You can ask me. I can help you through TeamViewer and other platforms that can help me get into your system and help you in whatever that you want to do. And that's it for today. Enjoy the rest of your day. Goodbye.